Hello, we're going to be talking about Rolle's theorem today. Rolle's theorem is a special case of the mean value theorem. So let's go through what Rolle's theorem is first, and then we'll do a couple of examples. So it says, let f be a function that is continuous on the closed interval ab and differentiable on the open interval ab. If f of a equals f of b, then there exists some c in the interval such that f prime of c is 0. So let's draw a picture for this because I feel like that's going to make it make more sense. So I'm just going to draw some graph. And let's say I have some x value a and some x value b. And in Rolle's theorem, it says that f of a equals f of b. So I'm going to pick some y value and say that that's both f of a and f of b. And so I'm going to have my points there. Now, f is my function, and we know it's continuous on the interval and differentiable. So I want you to try and draw some sort of connection between the 2 points that's continuous and differentiable. Now, Rolle's theorem is saying that if we are continuous and differentiable on the interval, then there has to be some other x value c such that the derivative is 0. So like I said, you can try and draw a connection such that that isn't true, but you will find, maybe I should have drawn the curve first, that there's going to have to be some c, there's going to have to be some c such that the derivative is 0, and let's say this is c. And here, our derivative is 0. And that is what Rolle's theorem is saying. So what kind of questions could you get surrounding Rolle's theorem? So for an example, I'm going to give us a function. And let's verify that the conditions for Rolle's theorem on the interval -2, 2 are met. And let's find the value c guaranteed by the theorem. So first thing is, this is a polynomial. Every polynomial is continuous and differentiable everywhere. So I'm going to say f is a polynomial. Therefore, and we're going to go by our theorem. So I want to show I'm continuous on the closed interval and differentiable on the open interval. So I'm going to say, therefore, f is continuous on -2, 2, the closed interval, and differentiable on -2, 2, the open interval. The second thing that we need to check is we need to check the f of a equals f of b part. So here, keep in mind that your a is -2 and your b is 2. So I want to show that f of -2 equals f of 2. So just keep this in mind. I'm going to move it. But let's do f of -2. That's going to be -2 to the 4th. And we get 16 minus 8, which is 8. Let's check f of 2 and make sure we also get 8. Okay, it's also going to be 16 minus 8, which is 8. So I'm going to say, therefore, f of -2 equals f of 2, because they both equal 8. So these are the conditions I need to check for Rolle's theorem. So I'm going to say, therefore, by Rolle's theorem, there exists a c in the interval.
Okay, I found.
Therefore, by Rolle's theorem, there exists a c in the interval such that, if I can spell, such that f prime of c equals 0. So now that I've done that, let's actually find that c value. So what I need to do is I need to find the first derivative of the function and set it to 0, and once I do that, I can solve for c. So first derivative, so I'm going to make it in terms of x first. There's my first derivative. Now let's set our first derivative equal to 0, and now I do want to put c's in there. Let's set our first derivative equal to 0, and the result of that is going to be the c that is guaranteed. So let's factor. Oops. Okay, so we're going to get c equals 0, 1, and -1. So these are the three values. I actually have three values for this problem that are guaranteed by Rolle's theorem in this case. So here's an example.